So I think everyone here has learned Crystal at some point. And learning is really important for the growth of a language. Thereby, I will be talking about why and how to improve the learning experience for Crystal, what is Exorcism and how it works, and challenges in the future. So most often today, most people learn Ruby and then they learn Crystal. It doesn't have to be, I learn Ruby and then directly after I learn Crystal. It's mostly often a time between, but that's often the case. So we need to make that all road leads to Crystal, meaning it shouldn't matter which background you have, you should be able to learn Crystal whatever what. I know there is multiple people in the community who even has come from other languages than just Crystal, like Python or C++. And then the UN, United Nations, has a goal, I think it's 17 sustainability goals. And the fourth one is to make quality education for everyone, to make a sustainable future for the whole world. And this includes making education free and accessible, non-discriminatory, meaning it should not depend what your age is, your gender or ethnicity, to what you have access for type of education. And we also need to offer high quality educations. So one way of making learning easier is by having a directed learning path. Instead of making a student have to select which concept they learn, we give them a selected path. And this makes so learning gets more efficient because we know which path is the more efficient one instead of a student needing to figure out by themselves. Like, it becomes very hard if you don't know what a number is to start with what is a complex number. And it makes for less confusion also. So what is Exorcism? Exorcism is a free and accessible and open source learning platform. We offer an online editor, which means that you don't have to install anything to get started on learning your next programming language. We offer free mentoring by real humans, and the language has 67 languages with over 3,500 coding exercises. So, now I jumped to the end. Okay, let's go back. So this is the starting page when you go to Crystal. You're met with a Hello World exercise, which is an exercise set up to see that your environment is correctly set up. And when you complete an exercise, you unlock the rest of the 112 exercises. So when opening up the Hello World exercises, you're met with two options. One is our online editor, and the other one is our CLI. So when opening up the online editor, this is what you're met with. You're met with instructions on the right side and an editor. This editor is a code mirror 6 editor with syntax highlighting, as you can see. And in the top, you have the possibility of selecting different files. In this case, you only have one. And you can also see the tests for the exercise, as you can see here. And we can also run the test directly in the editor. No install is required. And we get a nice result with saying what is wrong. We can see expected, and we can see in this case it's saying goodbye Mars, and we are saying what we should have got, which is hello world. So when fixing up the error, so it says hello world, we will get it to complete, and we can now submit. But we also offer a CLI, which means you can work directly in your editor. As I saw in the first picture, we can actually get the script to just copy-paste into our terminal. And this will open up a folder with both a solution file and a test file, so no other configuration is required, and you can start editing right away. So when running tests is exactly as you would expect. It's just CrystalSpec, or we also offer Exorcism test, which is our unified keyword, which will work for, I think, most languages on the website. And when you have come to a solution you like, you can submit it as easily as writing submit. So the Crystal track on Exorcism has 24,000 submissions, and we have over 190 students, and we have given 700 analyzer feedback this far, and the analyzer we launched for, I think, 20 days ago. And so we offer automated feedback through our analyzer, which is an automatic system which makes so we don't have to give specific feedback to each person, and instead we can figure out certain errors a student makes and thereby make an analyzer to pick up those kinds of error and give the feedback to the student. We have, it should say practice, but we have in total 117 exercises. 17 of those are concept exercises, and 100 of those are practice exercises. The difference is a practice exercise practices on general programming, while a concept exercise practice on a specific concept. This can be string, arrays, or other things. And we have in total 18 language concepts. We use a custom test generator, which means most of the tests we don't actually write by hand, and instead we have an automated system which writes those for us by using a template. And we also offer, as I mentioned earlier, mentoring. So to make this possible, we have tooling. We have our static code analyzation tooling, which is made of our analyzer and representer. Our analyzer actually includes the representer, so it actually runs a representation of the code in the analyzer. I will speak a little bit more what those are in later. And then we have our dynamic code analyzation, which is our test runner, which is what makes the possibility of running tests on just a website and no install required. And then we have a development tooling, which is the test generator I talked a bit earlier about, by making so tests can be created automatically. And then future projects include a document generator, which is the possibility of generating documentation more dynamically. This hasn't I started on, but I'm planning on it. So our analyzer is the tooling which makes us able to give feedback just through looking at their code and having it automatic. And it's made of two pieces. It's made of Amoeba, which is, I think most people here should know about it. It's the automatic static analyzer. And then we have our custom-built Exorcism analyzer, which focus more on checking the exercises of errors student makes, while Amoeba more checks general language concepts. So here is how our part of the tooling works. So we do an AST parsing and then we check through that through the visitor syntax library in the standard library. And then during the analyzation, we create nodes with information about the code used. And then we compare those nodes with information about what kind of error a student can have made And when we have done that comparison, we know which feedback we can assign. So here's an example. We can see the solution, and we can notice two things. On the last line, for example, we can see that we are missing a new line at the end of the file. And if we're looking at the defining of the constant, we can see that we are using two I64 and two I32. It will be more idiomatic to instead just write underscore E32 instead of using a method. So let's show you a quick example of the analyzer in practice. So here is our test runner running to see that the tests are processing. And then we can press submit, and we get the feedback right in our editor saying Ameba picks up the trailing new line at line 13. And our own analyzer picks up that you should instead define a number with underscore and then the number type instead of using the two I64 method. Our second tooling is our representer, which allows us to compare solutions. This is perhaps not the most common thing you have to deal with, but we have to. And I like to think about it as, say we have 10,000 students and everyone does an exam, say they need to solve Couliat's conjecture. It will take a lot of time to need to give feedback to 10,000 solutions. Instead, we can make a system which groups these kinds of solutions into groups by looking at the syntax, because most of those solutions will be very similar, but they will likely be a little bit different. They will use different names and stuff like that. So this system makes us possible to give feedback to multiple students at the same time, and I will show an example later of how that is possible. And it also makes us able to group the solutions. So as with the analyzer, it starts with AST parsing. This works a little bit different since we're actually using the visitor library to actually pick up some of the names, because it's actually hard to predict which order we actually come into the file, and sometimes we miss certain names if we are not doing a visitor before. And then we are using a transformation, the transformation syntax library. This makes it possible for us to reorder methods. And this may sound really basic, but it wasn't that easy. But it makes so we can order methods in the order of the names. So if you write a method on top and I write one method on the bottom, it will be as same because it will actually sort those in the same location. And then we have a third syntax class, and that is using the transformer again. And that is by taking away all the names and replacing it by generic names. And then it stores all the names in a hash, and it writes out this new generic version with associated name. So here is an example. So here is two plain solutions. We can see that those are the same, but they are using different names, but the solution in themselves are the same. So what we do is we replace all the names by a placeholder name. So after using the representer on the plain solutions, we will have the same solution. And this is what makes us able to compare the solution. Moving over to the third, moving over to the test runner, we're using the v3 spec of Exorcism, which is the latest spec, which allows us to have test cases, which is having each test case being its own thing. Task ID, which I will speak a little bit more later. User output, so you can use P or puts in the code editor, and you will actually see the result. And then we also show the test code output. And it works very similarly as the other tooling with AST parsing again, but to get the output, we actually do use script injection in the spec file, which isn't a super rare approach on Exorcism. It's actually used pretty commonly, and it was thanks to Johannes I actually figured out this approach. So after injecting that script, which is what makes us able to get the output into a specific JSON file, we're running the tests, and then we're doing AST parsing, but this time, instead of the solution, we're doing it on the test file, and that is so we can figure out all the tests. And then we combine all the data we have generated into a single output, which in this case is a JSON file. So if we bring up this exercise, we will see that we can see the code just run for this specific case. And we see it's also grouped because we have different tasks. And we can see these different tasks in the menu. So you can solve a task and then move on to the second task. And we can group this by the task ID I mentioned earlier. And you can also see your output. So we are using P here. And you will see P in the test code output. So let's move over to the test generator. And that is our automatic spec file generator. And it makes development a lot easier for us, maintainer of the library. And it reduces human error since it's not done by hand, it's done by machine. And we use a modular design, which means we can have plugins in the system. So how does it work? We load a template file and a JSON file. This template file is an ECR file. And then we have a TOML file with all the test cases, and we can remove test cases in that TOML file. And that will remove the test case in the JSON as well. And then we parse the ECR file, and thereby it combines the JSON file into the ECR file. And then we format the newly generated spec file and write it. So here's a problem spec example. Problem spec is where we host all of our exercises. And this problem spec applies to all the languages on the website. So all the languages uses the same basic tests, which is pretty fascinating, thinking that 67 languages can use the exact same JSON file. So we use this JSON file to generate the test case. We take the description, the property, and the input and output. And then we put it into the ECR file. This perhaps looks messy, but thinking it's used, I think, 7 lines, it's very compact, thinking we can have test cases with 100 test cases. So we generate a describe block, and then we have it, and then we have input and expected, and then we compare those. So let's show you this example. As you can see, the spec file here is empty, so let's run this script. And after running it, you can see that the ETL spec file comes up, and we have all our test files generated for us. And this saves a lot of time for us, since we don't, every time the problem spec updates, we only have to run the script, and we get a newly generated files. So let's move from tooling to a little bit about mentoring. So we offer mentoring by real humans. And we believe that you don't know what you don't know. So And by using mentoring, you can learn language-specific conventions. Like Christina mentioned about using structs instead of classes. And for example, learning with other is also very fun. So let's give a quick example. This is someone needing help. They don't understand what is problem with their code, and I give a hint to what they should be looking at, and then they solve exercises. Moving on, we have our syllabus, which is our language concept-specific learning path, and here you can see we have basic, bools, numbers, number types, classes, and a lot more concepts. And all of these concepts comes with their own unique exercise. So when you read our text about the concept, you can practice it in practice by solving an exercise about that concept. And our text usually looks like this. This is the basics, and it gives an introduction. In this case, it gives an introduction about the language. It talks about it being compiled, a short history about the language. We also have community solutions, and this may be unappreciated, but you can actually see how other people solved a solution. So you may not like, oh, I think this problem only have one solution, but you can look here and you can see that people are using a lot of different solutions. Like here we're using scan, here we're using split, yeah. There are often like a bunch of different solutions, which I found really interesting. So let's speak about what we have done in the last year for the track. So in January, we made our first test generator, which was the automatic spec file generator. In February, we made our test runner, the V3 test runner. And in April, we made our first operation, which this made a huge update to Crystal. We were, before this, using Crystal 1.3, but after this, we were using 1.8. This was our first update to the representer. And it was also an update which allowed output in the test runner, and we did huge improvements to our CI. Later in July, we made our operation Unix, which is the update to Crystal 1.9. We did huge improvements to the representer, a lot of bug fixes, and a lot of improvements. We also launched our learning mode, the syllabus I mentioned earlier, generator improvements and exercise improvements. Then we had, in late September, we had our update 12.23, which launched the analyzer I spoke about earlier, 6 new concepts. And then in October, like last week, we launched our Operation Obsidian, which came with Crystal 1.10, new analyzer comments, the representer as a shard. This is a pretty big thing and was the thing which allowed us to integrate the representer in the analyzer. Before, the analyzer was, the representer was pretty non-library friendly, but we made a pretty big push on making it more library friendly to not only for ourselves, but also to make it possible for other people to use it. We launched 3 new concepts, and we added a practice tag to exercises. So here's a bit short, 2 new concepts. The representer has now a CLI and API mode, improved documentation, and a bunch of other improvements. The analyzer is integrated with the representer and a bunch of more changes. So on Exorcism, we have a so-called 12-in-23 challenge, which is a challenge where you should learn 12 different languages, or at least try 12 different languages during 2023. This month is, of course, Object-Oriented October. And Crystal is, of course, one of the languages since it's object-oriented. And every month, we offer exercise challenges and an exclusive badge for completing one language in this group. And we can see the growth. See, in the last month, we have had a really upwards climb, but generally, the last 2 years, we have been on the uprise. It has been a more steep slope in the latter part. So let's talk about a bit of the challenges. The test generator has, which I spoke about earlier, was a bit tricky to get right because I don't actually know how the JSON file of the test case looks like. So I tried to find an approach which works, and since I don't know how the JSON file looks, I will have a JSON any object. And this didn't work well with most templating engine. What it worked great with was ECR. Problem with ECR, for people who don't know, is that ECR is a macro, which means it has to load the template at compile time. But we couldn't really do that. And then we had another issue where compile time taking too long. And this isn't really solved, but I think we are looking into using an interpreted execution, which will also generally improve performance and the waiting time for students. Standard output was also an issue, but thanks to Johannes, as I mentioned earlier, we solved that. Macro representation is an issue as well, because the syllabus tree looks a little bit weird with that. The future, our goal is to implement over 30 concept articles for exercises which says approaches for a certain problem. The document generator, which I mentioned earlier. And we are also looking for contributor. This can be anything from just mentoring other students, opening up issues. I'm really happy when I see an issue, and often it's very easy for me to fix. And just help developing. With the document generator, I'm hoping to make developing a lot easier. Yeah.
Yeah, let's take some time for questions.
We have questions from YouTube. Maybe I'll just give them the text. You can read the question yourself.
Okay.
From the same.
Just curious, who should be something to make Crystal available on? Wait, what? Oh.
Don't worry.
Okay.
So one question is the analyzer. Is it open source? Is there a way of contributing to it?
Everything is open source in the way that it's open. The analyzer is. I liked. Yeah, it's a bit tricky. The track and all the problems are open to contributors. The analyzer, I think I like the approach of, opening an issue and having a discussion before doing actual.
Oh, this is what I'm talking about.
Yeah. So I think opening up an issue, but yeah, I'm generally open for contributions.
Is it possible to use independently the analyzer? Like anyone can use an analyzer in their computer?
I forgot to mention that, but all the tooling out of the test generator runs on Docker containers. So you can, if you have a Docker setup, you can just start it up. But it doesn't really have a proper API or CLI mode as the representer does.
All right.
I have a follow-up question about the analyzer. So, super interesting stuff. I was wondering if you had any thoughts about static analysis in Crystal more generally, and what the challenges were, what was easy. Also, maybe there were things about the language that made it more difficult than otherwise.
I mean, there are a lot of things which are easy, better than other languages. And then macros are, when doing static analyzation on those, are quite tricky. And I haven't really got that nailed down yet. Hoping to get a better approach. but comparing to other languages, yeah, I think the experience.
Static analysis, like we've got Amigo, which is great. But,
Yeah.
It's interesting to see what you thought was missing and then you've done separately.
Yeah, I mean, what we need is, students have a problem, and we can very easily tell that you should use this approach and not this approach. Like, if I have a Boolean, you shouldn't really compare that Boolean hard-coded with another Boolean, because creating a new Boolean off a Boolean becomes, I don't know if that makes sense, but say you have a variable with a Boolean, and then you're comparing that with another Boolean. That's a very common pattern I've seen. And you don't really understand what a Boolean is in that case, because a Boolean represents a true or false value, and you shouldn't compare it with another Boolean to get a false or true value, because I see very often comparing a variable with true with hard-coded true, and that is not really something that you should do. But it's apparent on all languages. But going back to the going through AST code in general, I think it's pretty good. There are, like, I've done AST in other languages like Swift, and that takes super long time to compile that library. It's really slow. I'm hoping they will improve it. But yeah, out of the macros, AST, I think it's really good.
I have one more question from YouTube related to groups. The group of students can be made like ad hoc, like people who wants to group and study together. They can make a group. It can be a company, and so on, or is it made by the tool groups?
You mean the grouping of solutions?
No, grouping of people studying.
Studying.
And also mentoring in particular.
Yeah, the mentoring, you have two options. You can either select to get one of our mentors on Exorcism, and that can be anyone, but they have to meet our criteria. And then you can send a direct link through email or Discord or whatever your media of communication is, and you can send a direct link to make them being able to mentor them. There were development of like a group mode, but I haven't heard. That development hasn't continued in the last little bit, so there are no real group mode.
Okay. Questions here?
I'm a little curious about the auto-generated documentation. How do you practice about that?
So I didn't really go in detail, but what we have is 3 different documents of I mentioned the concepts. And for us, it will be a lot easier if it's just one document, and then we use templates to generate the 2 other documents. Because we have, I like to call it one head document, and then we have 2 smaller documents. So that's how we're planning to do that. It's not going to be like we have a document generator for the language. It's not going to be really like that, where you take code and making it into an HTML file.
And the last one is the certificate is something that you can. So no, hold on. Let me read it so I don't spoil it. Are there any certificate at the end of the course that you can then link to LinkedIn?
No, there is no. I know this has been requested, but no, there are not. But it's a free learning platform, and if we start offering certificates, we will have to require to check which level the person is on, and we do not really have a facility for that, and it will make it sort of required to make it a paid platform, and we do not have a facility for that.
All right. With that, let me thank you for your impact, and thank you.
Thank you.